Well, I've got 4 electronic loads over here, and you know what that means? No one knows what that means. I did it once. I'm going to be testing USB-C power supplies, and in this case, high wattage power supplies like this UGREEN 300 watt gallium nitride, big chunky heavy unit. And this is what I bought for my own purposes. I wanted a roughly 300 watt power supply for USB-C for a couple of devices. I really only need 250 watts, but I wanted some headroom on the power supply. I've never used a UGREEN power supply before. I have a couple of cables from them and a USB power bank, and they've been okay. Good quality. So I have a good feeling about this one, but we'll see. I'm going to test it out under load and just generally for noise and stuff like that, voltage fluctuations. Not noise in the Marco Reps sense of analyzing noise, but just more like voltage fluctuations. While I was searching Amazon for something like this, I came across another power supply that's even more powerful. This is a 700 watt power supply in very, very attractive packaging. I mean, the number of designers that went into this, I mean, Apple, like, they must have poached people from there like crazy. Yeah. But notice one thing, the boxes are quite different sizes. 300 watts, 700 watts. And maybe the UGREEN power supply is really no bigger than this one, but the box is just bigger because it contains, I don't know, a pot of gold and maybe a case for it. So before we put this guy through its paces, and really, I just want to load this down as much as possible and hope that it goes on fire so it's something interesting for the video, because I have zero confidence in this. But I'm going to look at the UGREEN first. I'll do a perfunctory unboxing. I don't think there's really going to be a lot to see because it's a power supply. But, you know, some of you might be curious about how it's packaged. And, ooh, it's chunky. Yeah, so most of the weight of this package is the power supply. And like I said, this is gallium nitride. So the fact that it's so chunky and heavy leads me to believe that the 300 watt rating is reasonable. You know what I mean? The first port is labeled 140 watts, second 100 watts, this one also 100 watts. This one not labeled with the power, but since this is capable of 300 watts output, I'm guessing you plug your high wattage ones into these first 3. Don't know about this last one. And USB-A, probably a reasonable amount of amps. 5 volts, 3 amps max, so 15 watts, 18 watts at 9 volts, and also 18 watts at 12 volts. Alright, so not bad for Type A. And that bottom USB-C port is 45 watts max. That's why I didn't label it, because that sounds low compared to the other ones. Nice rubbery base. And by the way, I did talk about this in my video on the Slim Q power supply, where it was designed to lay flat on a table, and where it was laying on the table, it got extremely hot on the back because it was, well, insulated. But this is clearly meant to stand up because the feet are here, which means more surface area exposed to the air, better cooling. So right away, I like this design. It is grounded. That's stuck to that. Anything else in the box? I'm guessing a power supply cable. Ooh, okay. Probably a high current capability USB-C cable, but it doesn't say. Oh, 240 watts. It's embossed on the connector. Good. I can't usually be bothered using these Velcro straps. I mean, they're simple to use. It's just, you could just coil up the cable and throw it in your bag. You don't need this. At least in my opinion. And it goes in the garbage just because I have so many of them already. And power supply cable with a slightly fancily designed plug. Kind of looks like maybe Apple inspired a little. And 2 Velcro cable. And a ferrite choke. Huh. And that is it. But really, what more do you want? In fact, oh, well, I guess what more you might want is an instruction manual type thing. But they were actually quite generous in including the USB-C cable. By comparison, let's check out this undoubtedly high quality 700 watt USB-C and A power supply. Yep, that all checks out. Oh, and then they have the front of the box once again. Brilliant. This is like total no-name drop shipping bullshit because it doesn't even have a brand name on it. It just has a model number. Like, oh, and this is the same thing that was on that pamphlet as well. Yeah, so completely anonymous. Significantly lighter than the UGREEN power supply. Although, to be fair, well, it's probably about the same volume. It's a little wider in this direction, but not as fat and not as deep. And not grounded. Comes with a power supply cable, which is extremely thin and a little flimsy feeling. It did come with a USB-C cable. Kind of curious what the voltage drop on this is going to be. And this one is not labeled as far as current carrying capabilities or whether it's USB 3 or not. I'm guessing not. But who cares? I guess I should discuss the ports on here. There's not much to discuss. It alleges 120 watts is available at each of these first 4, then 2 of 65 watts, then a bunch of USB A's of unspecified amount, at least unspecified on there. But we can see the front of the box claims 4 amps max. Wait, I just realized this is max 65 watts, 20 volts, 3 amps. 20 volts, 3 amps is 60 watts. I don't know where you're getting the extra 5 watts from, buddy. The other ones make sense. Yeah, 20 times 6 is 120. Okay, fair enough. And 4 times 120 is 480, 2 times 65 is 130. So that would be 610 watts total. Not 700 like it claimed when I bought this thing. In fact, does it say 700 watts on the packaging? Again, I'm being prejudgmental about this thing, but I think you can see why. And also, no clear orientation, like there's no feet on this thing. I guess this would be the bottom because it has the printing on it. So you probably are intended to stand that up, plus then the writing would be right side up. So again, good for cooling. It's nice they encourage you to stand it up. But will it stand up to load? Okay, I'm sorry. I won't do that again. So, first off, the UGREEN. Let me plug that into a power strip just off camera. It did not blow up. That's always good. One thing I don't like is there's no indicator LED. I like an indicator LED personally. Not necessarily a super bright blue one that's obnoxious and lights up the entire room, but like a nice subtle green one would be nice, especially because they're called UGREEN. You'd think their color would be green, not purple. But hey, who am I to argue? I guess I should show you what equipment I've got here. Multimeter just for thermal monitoring. It's got a thermocouple attached to it, and I'm just going to tape this to the outside of the device when I'm doing the long-term test. I'll leave these running for quite a while, maybe a couple hours, maybe a few hours, see how much they heat up. And then the 4 of these are all just electronic loads of different brands, except the Rygals, which are both the same brand. 300 watt, 300 watt, 200 watt, and 350 watt max. So in combination, we can definitely load this up to 700 watts, if it'll even get near that in the first place. All right, let's try this guy with the UGREEN supplied cable. Hook it up to the electronic load in the lower right. We got 20 volts. And I believe I'm using these little USB-C power delivery chip modules to negotiate that 20 volts. And I believe it won't let it go higher than 100 watts. So the most we could get per port is 100 watts, but that'll be fine in this context. Set it to 5 amps, 100 watts, turn on the load, and there we go. 99.24, 22, whatever watts. 100 watts. Get another high current capable USB-C cable. This one's also a 240 watt cable. 20 volts down there. 5 amps on. And did that cause a voltage drop over here? 19.83. I'm going to turn that one off. 19.84. No, it's pretty well regulated. Okay. So the UGREEN's now supplying 200 watts. Alright, third port for the last 100 watts. Alright, we got 20 volts. I'm going to set the current to 5 amps. Turn the load on. Oh! It doesn't like that. Now the good thing is, even if this port was overloaded, I guess, it didn't like providing that much current on this port, these two are still supplying 100 watts no problem. That's good that the ports are separated like that, but let's try setting the current to 4.5 amps. No? Can we get 4 amps? Huh. No. Alright, can we even get 1 amp out of this? Okay, it'll supply 1 amp. It'll supply 2 amps. 3, okay, that's 60 watts. We're getting somewhere. But then I'm guessing it's going to crap out at 4 amps because we already tried that. Yes. I'm going to do 3.5. It seems to crap out some, so that's disappointing because, like I said, this is a 300 watt power supply ostensibly, and it does not appear to want to supply 300 watts. Oh, my bad. The reason it can't supply 140, yeah, I forgot, 140 watts is at 28 volts. It's 5 amps max on the first connector. And then USB C2 and 3 are both rated the same, so they should both be able to provide 20 volts, 5 amps, no problem. Huh. Wait. I was just looking at the manual to make sure I wasn't doing something wrong. It turns out I am doing something wrong. This does illustrate which ports you can use in tandem. Well, single port charging is fine. 2-port charging is fine. It looks like you use any 2 ports in tandem, but when it comes to 3-port charging, you can only do on the first 3 USB-C ports 140, 100, and 60. 140, 145, 140, 100, 22.5, 140, 145. What? Wait. Oh, there's more combinations. Okay. Yet more combinations. Wait. Is this also bullshit? I mean, technically it's not bullshit because you can get 300 watts out of this charger, out of this power supply, but the only configuration you can do that in is 140 watts on the first port, 100 watts on the second port, and 60 watts on the third port. And then there's a couple of configurations where you could get 285 watts, but in most of these combinations with 3 devices, the most power you can draw out of this thing is 285 watts if you're not operating anything at 28 volts. Huh. Well, that's unfortunate, at least for, well, both for testing and for my use case, because I really wanted 3 100-watt ports. I'd be taking a little less than 100 watts out of each of them to leave a little overhead, but yeah, this power supply is not going to cut it for my purposes. I did not realize that. This is kind of bullshitty, because from all appearances, first port's labeled 140, 100, 100. You figure you could take 100 watts then out of each of these 3 ports at the same time. But no, there are very strict requirements as to which ports you can use in tandem or in combination with each other. Lame. That's very lame. I mean, it is what it is. It's probably still a decent power supply. I'm still going to test it out. Well, that's a shame. I'm not going to be able to use it for the purpose I had in mind, but I will be able to use it for something. Just not getting anywhere near 300 watts out of it. Which in a sense is fine. I mean, I'm assuming running this with 300 watts of output would kind of stress it out. I always like to leave some overhead on power supplies. So they're not running at 100%, heating up as much as possible, damaging themselves internally. I don't know. You know what? I kind of want to see if this horrible power supply will actually provide more in the way of output flexibility than the UGREEN supply. Although something else I got to check is, are these ports truly independent? Like, if I have a power delivery device demanding 20 volts off this receptacle, does that mean all of these get set to 20 volts because they're on a common rail? Or maybe all of these? We'll find out. For now, let's see if it blows up. First power on. Okay, didn't explode. Also, no power LED. Alright, let me start with the top port, I guess. We got 20.3 volts. That seems rational. Again, I'm just going to jump right into the 5 amps. Okay, it's supplying 100 watts. A little bit of voltage drop, but it's probably on the cable, not necessarily from the power supply. Let's try another port. 20 volts. Whack another 100 watts onto that. Oh, both of them died. And then I turn the load off here. Load's still on here, but now it won't renegotiate. I bet if I turn the load off, yeah, it reactivates that. We got 100. Okay, let me turn that one off. Flip this one on. Okay, so we're doing 100 watts off this port. Let's put this one back on. And no, that makes the whole power supply crap out. So it's not even capable of 200 watts. I guess to be fair, let me try the top port and the bottom port of the 120 watt ports. Oh, interesting. Okay, so the top port and the bottom port together can output 200 watts total. Then do I dare try, let's say, the third port down? It's going to this load, 20 volts. I'm going to set this to a conservative 2 amps. Okay, 240 watts total being supplied. Can we get 3 amps? 3 amps. Cool. 4. Wait, so can it do 5 on this port as well then? No. Alright, but it knocked out this load, but not this one. So I think these ports are paired up. So the first 2 ports are paired together, the second 2 ports are paired together. So, okay, that's, I mean, it's better than I thought it would be. We got 200 watts at least out of this thing. Then there's 3 65 watt ports below that. I'm going to plug this into the first 65 watt capable port. Let's turn these 2 back on at 100 watts each. So let's go easy on it. Instead of 65 watts, we'll do 60 watts. Yeah, okay. Alright, let me bring in my last electronic load. And I guess I should hook this up to the other 65 watt port. I bet those 65 watt ports are paired. I think I said there were 3 of them just now. I meant 2. There were 2 65 watt ports. Don't know what I was thinking. Anyway, on that port we got our 20 volts. We'll set it to 3 amps, I guess, right off the bat. Let's see what happens. Ooh! I'm actually surprised. Alright. So we got 60 watts here, 60 watts here, 100. So that's 320 watts at least. It's already beating the UGREEN. How crazy is that? How hot is that? It's not even getting hot yet. But I am going to run this for a protracted period of time, so we'll see how hot it gets eventually. But I am actually surprised that it can even supply this much power. Well, I did lie. I have a couple of more, I guess you'd call them electronic loads. A bit of a different form factor. A bit more rough and ready, but they should work. Whoops, well maybe that one won't now that I dropped it. They have USB ports here for input, so yeah, let's see. And this is starting to get warm on this side. Not hot yet, just warm. Micro e micro USB, micro e micro USB, micro e micro USB. Alright, well I got these guys hooked up to my Anchor power supply just to power the devices, not to load it up. Why is this one in Chinese and this one's really not in any language? In the brief time I was messing around with these two, this is now actually hot. Still providing the combined 320 watts though. The voltage looks like on this one it's drifted down a little, but on this one it's drifted up. That's weird. And by the way, with the voltage drop on this cable, that's got to be supplying a decent amount more than 20 volts. And what I've got here is very simple. It's just a USB cable that I messed up on purpose so I could check voltages and such. 5 volts. Okay, it is outputting 5 volts. Alright, let's try this again. I got a couple of cheap ADA micro cables. We're now drawing 1.62 amps at 4 volts. That's got to be voltage drop on the cable, right? Because if we turn the current all the way down, we got 5. Then immediately once we put any current on it, the voltage drops precipitously. Well, let me just see if that's this cable just being... Although you should be able to run an amp through this cable, even if it is pretty thin. Yeah, oh, no, what was the cable? 1 amp. Wow, this fine adjustment is really not that fine. Alright, 2.8 amps. That reached the end of the fine adjust limit, so let's go with some coarse adjustment here. Oh, got it right back up to 2.8. Nice. Looks like it's really hitting its limit at 3 amps. It should be able to supply 4, according to the specs. Yeah, 5 volts, 4 amps for all those bottom ports. But that could just be because this thing's being loaded down too much otherwise. It's still doing okay in that regard. But for now, let me just turn off the loads. So now it's completely unloaded. And let's see if we can go a little above. Oh, okay. Oh, nope. Nope. 3.23 amps, it's still crapping out. 3.2 amps. It cannot do 4 amps on these ports. Alright, so we can do 3 amps. I mean, that's only an extra 15 watts, and that's being generous, assuming that voltage drop is on the cable and not the power supply. And I'm going to see if I plug this into I'm going to plug this into the second to last port next to the other USB Type A that I have plugged in here. I want to see if those ports are also in tandem. Oh yeah, now we're seeing 5.26 volts, 5.28 there. Yeah, these must be in tandem, because once I put any load on the other one, it just causes this one to crap out. Cool. Not really. Alright, let me try the next port up. See if we can put some load on that. Yeah, okay, so the ports look like they're pretty much paired up, except for the 65 watt ports, because those are able to individually provide, well, at least 60 watts as I'm testing it right now. Yeah, and that other port seems to max out at just about 3.3 amps. So we'll stay right under that. So about 15 watts here, about 15 watts here, so that's 30 watts total from these guys. If I turn all these on, that'll be 320 watts, so 350 watts total with all this stuff powered up. And yeah, I mean, it's doing it. You can't deny that. I mean, of course, 350 watts is exactly half of its rating. So not great in that sense. Ooh, and it's really, really hot now. Oh, and in theory, it actually should be capable of 360 watts total, because let me set these to 3.25. Yeah, it's able to supply it. All right. So now we're doing 65 watts each here, 130 watts, 100 watts, 100 watts. So that's 330, plus the other 30 from these two guys. So that's 360 watts. That, I believe, is probably the maximum you can squeeze out of this thing, because the port's labeled 120. Oh, they're actually labeled 120 watts. So I guess I should push it up by another amp. All right, let me set these to, can we do 6 amps here? No. Oh, interesting. So when this one crapped out, this one did as well. That's one of the 65 watt ports. So apparently one of the 65 watt ports is tied to this one. Let's put this back to 5 amps. And then I bet if I hit 6 amps on this one, that one's going to crap out. Oh, this one crapped out too. But not this one. That's interesting. So this USB-C port. Anyway, let's bring this back to 5 amps, where we're okay. All right, so let me not leave this lying flat, because it's just going to get hotter than it. Oh, it's really hot. All right, so yeah, it looks like the maximum you could squeeze out of this is 360 watts, which is just about half of its alleged total capacity, which in theory is fine. It's just, it hasn't been running all that long, and it's already too hot to touch on the side. So this is garbage compared to what it says it is, and probably garbage in general. But I guess let's see how clean the power is off of the two power supplies on the oscilloscope. Like I said, not really looking for noise in like the nanovolt range, more like looking for the noise in the 100 millivolt range, because most USB-C devices would accept a fluctuation of plus or minus a few 100 millivolts. So that's the type of area I'm concerned with. All right, well, here's the setup. I got channel 3 on the scope connected to the USB output that's connected to this electronic load. Now, this is a really high noise measurement from environmental noise, because although this BNC cable is shielded up until this point, it's not there. And then it's also, of course, not shielded here either. So it's going to pick up a lot of environmental noise. I'm really just looking for any, like I said, major fluctuations on the order of 100 millivolts or a couple of 100 millivolts, because really any equipment you're going to be plugging into a USB-C power supply like this, you know, a laptop, a phone, whatever, almost has to be able to tolerate a variance of a few 100 millivolts, because otherwise you plug your phone into one slightly off USB power supply and it blows up your phone. Obviously not acceptable. There's going to be voltage regulators and all sorts of other stuff in your devices that'll smooth that out for the components in your device, so I'm not too worried about that. And just to see noise in the power supply in general, I have a USB Type A cable plugged into the, well, Type A port, and it is connected to a scope probe thusly. So it might pick up a little environmental noise right there, the rest of it's shielded, but this is just so we can see if there's noise on the power supply on an unloaded port, like this one. So for example, as we increase the current consumption on this port, are we going to see more noise on this port? Ideally we shouldn't, but in practicality I'm thinking we will. But of course, I don't want to make assumptions, let's see for ourselves. And you're not going to have to look at the scope like this. I'm remoted into it on this computer so we can look at it in much better quality, although with a little bit of a slower refresh rate. And you can see right away here, the blue trace is that 5-volt output. You can see it's stepping down 8 times and then jumping back up. This is with the power supply completely unloaded, and this is on the 5-volt rail. Now, of course, as you can see at the bottom of the display, the blue trace is at 5 millivolts per division, so we're really only talking at about a 10 millivolt variance there. It's nothing I'm concerned about. I just found that weird. And you can see tons of noise on the orange trace. Again, I'm not going to be looking at it at this current scale of 10 millivolts per division, but I just kind of wanted to show you what it's like. That's all environmental noise. And just to see if the blue trace is environmental noise, I mean, I don't see why it would be. If I unplug that, yeah, there we see lots of noise. So that's definitely coming from the power supply. As for the orange trace, as you can see, tons of noise from the environment. And this scope is on AC coupling, by the way. So what I'm going to do is bring the orange trace down to 100 millivolts per division, which pretty much obfuscates most of that noise. And like I said, at 100 millivolts per division, I am kind of fine with whatever. Okay, well, let's see what happens if we load it down with the usual, let's go right to 5 amps. So as I toggle it on and off, you can see the 5 volts jumps a little bit. And I'll look at this on a slower time scale later, just on DC coupling, just to see what that's looking like. That's with the load off, load on. But you can see the orange trace, which is the actual output that we're measuring, remains pretty solid. So right now that load is on, but now let's get the power supply a little bit closer to its maximum. Alright, and then finally, we should be able to pull another 60 watts off of this port. Alright, so now we got 60 watts off of there. So now we're pulling 260 watts out of the whole power supply. And, I mean, I'm not really seeing any difference on that orange trace at all. That's very nice. And just to sort of make sure we're looking at apples to apples, like I said, that noise that was in the blue trace was about 10 millivolts peak to peak. Right now they're both scaled at 100 millivolts. And well, you can still see the voltage fluctuations on blue trace at this scale. It's really minimal. And I think this scale is representative of what your device would see, or rather what it would see as meaningful. In other words, I think, you know, your device isn't going to be affected by this, even though this looks like a lot of variation on the scope. At this scale, that's really minimal to a voltage regulator that's upstream of this, or downstream of this power supply. Alright, so frankly, for my purposes, the UGREEN looks pretty good. There's nothing wacky going on here. Let me just change it to DC coupling and see if we get any longer term drift on the output. So right now for the orange trace, which is the 20 volt USB-C output, we're at 20 millivolts per division here, and I have the offset set to 20 volts, so it's centered on the screen. Right now we're loaded down with the 260 watts. I'm going to turn off each of these loads in turn, then turn them back on, see if we see anything weird. Oh, and I'm going to change the time scale. Now let's do 50 milliseconds per division. And it's free running, I'm not triggering anything right now. So let me turn off the 60 watt load. Rock solid. Turn off the 100 watt load. Rock solid. Now I'm going to turn off the 100 watt load that's connected to this port. Oh, okay. We did see a bit of an overshoot when it turned off. Oh, I gotta change the offset again. I hate how it scales the offset when you change the scale. Alright, load's off right now. Let me turn it on. And let me just change my trigger for that. Alright, well, we're at 200 millivolts per division, so it looks like maybe a 500 millivolt excursion. I mean, that's not horrible. And that's when it's turned on. And when it's turned off, ooh, it's sharper and lasts longer. And so that's when turning the load off. And now we're at 500 millivolts per division, so that's... Oh, the voltage was actually being pulled down before that, so it's a little below 20 volts. So it's like a 1 volt excursion to 21 volts, and then it settles back down and then after about 35-ish milliseconds, it settles back down to 20. So I'm guessing it's just spiking a little too much charge into the output capacitor, considering there's no load, and then that capacitor discharges back down. I mean, 1 volt, not really a problem. And again, that's when you disconnect the load. That's right after you disconnect the load, so that really shouldn't damage any devices or anything, because the device wouldn't be pulling any current at the time. So, and besides, 21 volts also probably not going to damage any USB-C equipment that you have. So, alright, overall, this UGREEN power supply performed pretty well. That's all I'm going to do as far as testing goes. I know some of you might be hoping for more in-depth testing, but this really seems good enough for me and my purposes. And what I, and probably a lot of you, want to see is how crappy is this thing. So let's take a similar look at it. And right away, just on the 5 volt output, we can see that this is quite a bit noisier. Not only do we have that sort of step function that it was doing before, we also have like a lot of spurious noise above it and below it. Now granted, it's still not a lot in the grand scheme of things, it's just a lot sloppier than the UGREEN. And I'm going to switch the orange trace back to AC coupling and put them both at 100 millivolts. Ooh, and that one's a lot noisier too. Alright, well anyway, like I said, same beginning test. We'll put the load that's connected to the scope on the top and the 5 volt just sort of monitoring cable on the bottom. Let's see what happens. Gonna load it down with 100 watts. Yeesh, that's at 100 millivolts per division. That is a lot messier. You see about an average of 200 millivolts peak to peak on the orange trace, which is the USB-C output, and 400 millivolts peak to peak on the blue trace, which is the 5 volt USB-A output. Maximum of about 400 millivolts peak to peak on the USB-C, which again is not really going to damage any devices. It just shows that this power supply has a much sloppier output than the UGREEN one. And now let's add another 100 watts to that load. And now let's... Oh. What is it doing? What the hell was that? I wasn't even doing anything right. What is it? Huh. Well, that's not good. Oh, it keeps trying to restart. I don't think it likes... Wait, let me get the scope screen in there so you can kind of see what it's doing. Ooh. Alright, it seems kind of stable right now. Still doesn't look good. Okay, let me put the other 100 watt load back on. Okay, we're now pulling 200 watts from it. Let me turn that off. Turn it on again. Yeah, you can see the noise gets a lot worse. And for some reason, the 5 volt port, it's really getting a lot worse. Right now, we're at about 1 volt peak to peak on the USB-A port. And another 60 watts worth of load. So now we're at 360 watts, which is about the maximum this power supply can handle. And we're actually clipping. I'm going to have to turn the scale up to 200 millivolts peak to peak on the blue trace. Yeah, now on the blue trace at a max of 1.2 volts, 1.3 volts almost peak to peak. Although the USB-C output's quite a bit neater at only a max of just about half that. So now we're on DC coupling. I got an offset of 20 volts on the orange trace, and it's at 500 millivolts peak to peak. I just want to see what kind of bullshit we get when we turn the load on or off. I'm going to turn the load off right now. I mean, we are getting quite an overshoot there. What if I turn the other 100 watt load off? And that doesn't affect this. They must have independent output caps. I'm going to turn all the loads off right now. So right now this is under no load whatsoever. You can see everything got a lot cleaner. Set up my triggering, and I'm going to turn the load off. And there we go. And so again, this one also looks like it overshoots to about 21 volts when the load turns off, and then the cap discharges, and then it stabilizes. Not too bad. Not too bad, to be fair. And then let's see what happens the other way around when we turn the load back on. And there's really no undershoot there. It's just going pretty much straight from 20.25 volts down to 19.75-ish. That's fine. That's actually performing better than I thought it would. And what if we load up the other outputs? Yeah, it's roughly the same. I mean, the noise in that 5-volt output gets ridiculous, but of course, if that's loaded, it's probably going to be less. Okay, well, in fairness to this guy, it's not quite the disgusting mess I thought it would be. Worse than the UGREEN for sure, but not a complete disaster. But what I really want to see right now is if I run this for a decent amount of time, an hour, 2 hours, at maximum capacity or near maximum capacity, I want to see if it melts down. This case has a very cheap sort of feel to it and sound to it. Just by comparison, that has a much more solid feel to it. And I'm going to guess that this thing is potted, or at least has a hell of a lot of that thermal goop. That, you know, the stuff that looks like caulk, but it's not caulk, all throughout it to spread the heat evenly and bring heat to the outside of the case. Because it really does feel very solid in all directions. Whereas this does not. It can squish it in a little bit. It sounds hollow. So, yeah, let's do that. Alright, I am now loading this power supply pretty much as maximally as possible. We're taking 100 watts here, 100 watts here, 65 watts, 65 watts, then an additional 15 watts using each of these. So that's 200, 330, 360. So we're back up to 360 watts coming out of this little guy. It's already getting quite warm. Actually almost hot. You can see we're monitoring the temperature up here on the side. That thermal probe's not completely accurately calibrated, but according to the non-contact thermometer, it's at about 50 degrees C right now, just sort of in the middle of that. I'll take a look at it with the thermal camera later, of course, too. And this introduces a new piece of equipment, at least new to this video. It's been featured in a couple of other videos already. It is a BK Precision 5335B power meter, which is monitoring the power going into the power supply from the mains. And so you can see right now it's getting 117-ish volts, about 5.2 amps. It's drawing about 414 watts with a power factor, a miserable power factor of 0.677-ish. And with that power factor, the number is really hard to see there, so you have to trust me. It's 0.610 kilovolt amps, so about 610 volt amps. And that is pretty poor, 610 volt amps to get 360 watts DC out of this thing. That's pretty horrible. So it's about 60% efficient, looking at it as a measure out of 360 out of 610 volt amps. Now, to the power supply's credit, it's still outputting 20 volts on all the ports where that's appropriate, and it's still, well, and it's hard to see. We're getting 4.3 volts there, 4.47 there. That could just be voltage drop on the cables, though. So the power supply is at least holding its own as far as voltage goes. I just don't trust it to hold its own as far as not going on fire goes. But, you know, we'll see. The power supply cord that shipped with it is not getting warm at all. It's, like I said, very thin and cheap feeling. Probably aluminum conductors if I had to guess, but at least it's not heating up. And by the way, this weird receptacle with all these banana plugs attached to it is so that I can route power through the BK Precision power meter from the mains. If you have a particular aversion to arbitrary wire color coding and electrical safety, or if you have an aversion to electrical unsafety, then yeah, you might not want to watch this part of the video. But it's relatively safe. I just realized it's kind of funny. In my last video, I had these gloves I called Muppet gloves, and like Oscar the Grouch himself, they live in a metal trash can. The reason they live in this metal trash can, which is empty, by the way, is that this is like I'm in the basement of my house right now. This is my emergency lithium-ion melted down battery containment vessel. For, you know, even a fairly large battery. I figure if I have a battery that starts melting down on my bench here, this sits right next to it, got the Muppet gloves, I can at least sort of scoop the battery really quick into this bucket, put on the lid. That's not going to put the fire out. It's not going to stop the battery from going through a nuclear meltdown, figuratively, of course, but put the lid on. At least it'll contain a lot of the smoke, And the lid's not airtight, so it won't like it cause this vessel to explode. Like smoke will still come out, air will still come out. Won't pressurize, but the handle kind of locks the lid on. And then again, wearing the Muppet gloves, I can bring this outside. Like this doesn't really have to. This bucket isn't to solve the problem. This bucket is just so that it buys me some time to get the battery that's on fire out of the basement and into my backyard in the middle of the lawn where it won't really harm anything. But the Muppet gloves are handy for handling hot power supplies, as we discovered in the Slim Q video a few videos ago. So yeah, the Muppet gloves live in a trash can. Okay, this thing is now... Ooh, I've been waffling on enough that this thing is so hot I could feel the radiant heat as I was talking and flailing my arms about as I do when I talk. So this says about 68 degrees, again centigrade, and the non-contact thermometer is saying 70 degrees, or thereabouts. Depends exactly where I point it. Yeah, let me get the thermal camera right now. I think now's the time for that. 94 degrees. Sorry, that was more than a bit out of focus. Yeah, 97 degrees right there in the middle. Oh, that side looks pretty hot too. 83.4. Yeah, but it's really the hottest right there by the ports. So around back, the hottest point is still right about here, and it's 85.8. The back side of it's not nearly as hot with like 76.5 degrees max, but the front of it is now up to 100 degrees. Oh, I didn't even notice one of the outputs died. Ah, I think it's starting to maybe thermally throttle a little bit. Because I just looked at the power meter and it's now consuming 320-ish watts. It's actually fluctuating up and down wildly. And this one, we're not getting output on anymore. This is one of the 65 watt loads, or at least as should be. Still getting 20 volts with no load, but... Well, there we go. Now it's pulling 65 watts again. I guess it shut off that port temporarily. Oh, this one's now turning off and on. Oh, one of these shut off just now. It's this one shut off again. Oh, that one turned back on. Yeah, so it's thermally throttling, and I guess as it cools down slightly, it just turned that back on. Well, I mean, it's behaving kind of better than I thought it would, because we're not getting a voltage drop. It's just turning off ports completely, which is actually better if you have devices connected to this, because an undervoltage could damage your device if it's overly aggressive trying to regulate that voltage back up to whatever it needs. It could cause your other device to overheat or get overly warm. I'd kind of rather it just turn off ports one at a time until it gets cool enough to operate. That's almost better than just reducing voltage or just flaking out in a haphazard way. But you still see these 200 watt ports are still good, even though it shut that off and shut that off. Both 5 volt ports are still operating. And this one keeps like turning off, turning back on. This one can't quite restart on its own, I don't think. And it's sort of stabilized in the front. Oh, no, it did not. I can now see 103.5 on the front. And at the side of the case, the hot point right here is 89.9. So where I have this is not even the hottest point on the device. I mean, it's trying its darndest here, but I kind of hate to think what it must look like on the inside. How hot some of these components are on the inside, in order for the outside of the case to be 103.5 in the front. I mean, it's probably sinking some heat out. Yeah, it's sinking some heat out through these cables as well. Like the connectors are getting hot. Ooh, ow! This connector's metal, and that actually was just so hot it burned a little. I mean, not badly or anything, but oof. Ooh, 105.9 maximum. Yeehaw. Actually, some of these cables and connectors down here are getting a little warm. Nothing dangerous, but... Ooh, it does not smell pleasant. It smells like burning plastic. Yeah, I mean, it seems to have stabilized. 105 degrees right up here. To be fair, though, I mean, the case isn't deforming or melting or anything. Oh, this one did shut off. And the voltage is not coming back, even without it under load. So this port died completely then? Because usually when I turn that off, the voltage would rise back up. What if we turn this one off? Is that going to bring the voltage back? No. No, we still got 20 volts here. And that port's still working. Oh, it came back. Came back while I was looking at this one. Yeah, 105.2 now. It really does seem to be stabilizing around that temperature. And the top of the case, we got a high point of 77.7. And I'm kind of curious what the temperature is on the bottom. High spot of 82.3 on the bottom. 107.0 right there. So it's still going up. So I don't know if I don't even know if it's thermally throttling on purpose, or if it's just getting so hot that it's causing components to fail, and then those components are cooling back down and it starts working again. And again, just to remind you, on the box, it does say that this should be able to supply 610 watts, although it said 700 when I bought it. It should be able to supply 610 watts simultaneously. So right now, I mean, this should be of no moment to this power supply. We're loading it at just over 50% of its rated capacity, assuming all these loads were on, which they're not. So, you know, according to the way it's marketed, it should more than easily keep up with what we're doing right now. And I think I said this in the Slim Q video, while 107 degrees centigrade isn't hot enough to really be a safety hazard in the way you'd usually consider it. Like, it's not hot enough to start a fire. I mean, I guess it depends what you're trying to ignite, but, you know, in a household, if I put a piece of paper on this, it won't burst into flames. However, the problem is if you're using this in a bedroom, for example, you got it sitting on carpet, it's standing up on my bench, but if it fell over and one entire large side of it was insulated, might get hotter and hotter and hotter until it does get hot enough to catch the carpet on fire, or melt the carpet or whatever. Then, again, if you're in a bedroom, maybe you accidentally knock over some clothes, throw some clothes across the room, lands on the power supply while it's supplying power to 2 laptops and a phone. Power supply can't sink any heat. If it doesn't have thermal regulation of a decent quality, then it'll just get hotter and hotter and hotter in that insulated ball of clothes until it does burst into flames, and the clothes too. And moreover, I made this point with the Slim Q charger, is that if I'm not wearing gloves, like let's say I'm not aware this gets this hot, I just bought it, start using it, it's supplying whatever, 300 watts, I think it's safe because it's well within its rated capacity. I'm done using it, I go to move it, pick it up with my hand, like just grab it, it'll burn me. I mean, it's that hot. Like, I really can't touch it for more than like half a second without having to get my hand out of the way because it just feels that hot. I mean, you know what hot stuff feels like. I don't need to tell you. But if you actually like grasped it in your hand and then threw it down, you could burn your fingers on this easily. So it's dangerous. I mean, there's no two ways of putting it. Now, if I did cover this in a pile of towels and completely insulate it, would it thermally throttle, or would components inside just desolder until it stops working and then it doesn't get hot enough to light the towels on fire? Maybe. But that's not a gamble you should take with the safety of your family and the safety of your house and etc. That's why I'm sitting here in front of the camera waffling about this and just talking to you, because I don't want to leave this thing unsupervised. And the power factor still sucks. I mean, that's another reason not to buy it. It doesn't have power factor correction. And it's really starting to smell. Like, my head's all the way up here behind the camera, but I can smell it pretty readily now. No smoke, though. I'll give it that. Oof. Oh yeah, that's really smelling like plastic. Is it getting soft? No, I don't think it is. Oh, it's definitely feeling a little crunchy or something. Like, maybe the sides are glued on. Like, it's not like soft, but the whole case is definitely creakier and more malleable than it was before. Like, do you think the sides of the case are glued on and they're just going to be able to pop off? No. I will open this up because I'm not going to be using this in my real daily life. I don't care about this thing. We will do an autopsy afterwards. I say autopsy like I know it's going to die. Of course, I don't know that. I just mean a post facto examination. 105 down at the bottom. Ooh, 111.2. Nice. Alright, well, it is quite late here. I'm going to call it a night because I don't know if this thing's going to do anything exciting, really. But I am tempted to, maybe tomorrow, bring it outside. Actually take like an old shitty towel I have, wrap this in it, load it up like this, and just see if it bursts into flames. Just for fun. Alright, let me call it a night for now. I'll be back with more tomorrow. Got everything connected to a power strip. I'll just shut that off. So now the power supply doesn't have power. Don't have to worry about it melting down accidentally overnight. Alright, same setup as before, but now we got the UGREEN power supply instead, of course. And right away we can see we got a power factor of 0.989, which is really good. So watts and voltamps are basically going to be the same. And we're consuming about 113 watts off of 100 watts going out of the power supply. Got 20 volts on this guy, 5 amps, and... oh wait, we had to arrange it in a very particular way. See, the annoying thing about this is that I'm going to have to keep this little instruction card, or at least look it up online, every time I want to figure out which ports I can take what amount of power from, because the markings on the front are virtually useless. And can we take anything off the USB-A port while we're doing all this? Well, it looks like for the USB-A port with all this load, it craps out above 3 amps at 5 volts. So right now we're pulling an additional 15 watts off of there. So we got 265 watts coming out of this. Oh, this one keeps shutting off though. I don't think we can use the Type A port. It must be on the same rail or something. Oh no, wait, it won't let me... wait, this should be a valid configuration. Oh, there it goes. Alright, so we got 100 watts, 60 watts, 60 watts, and an extra 30 watts there. Total of 250 watts coming out of it, and we have 275 watts going into it. I mean, that's quite a respectable 92.6% efficiency. So this is going to heat up a lot less than the 700 watt power supply right off the bat. We know that because it's more efficient. Less heat's going to be dissipated internally. And we're also putting less power through it, so, you know, for that reason as well, it's not going to heat up as much. Just realized I didn't have this on temperature. Now we got to play a bit of a waiting game, actually. Oh, and ambient temperature in here is about 25 degrees C. So, while this thing heats up, literally, at least a little bit, it's getting a little warm in the front, actually. I wonder if that's just the interface between these two connectors heating up. Alright, I made some space on the table. Let's open this thing up. This might be sonic welded or glued, but let's just see if we can get any purchase anywhere. Well, let me get the right tools for the job. What I'm going to do is take this off camera. I can't really pound on this table. It's going to shake the hell out of all the equipment that's on here. I'm going to put it on the floor, which is concrete, line it up in the seam, give it a few good pounds, and see if we get any poppage. Oh yeah. Oh yeah, there's definitely a seam there, as we can see. And I think it is maybe just glued. Oh yeah, oh that's coming off real easy. I just gave it a couple of light taps and voila. Am I going to be able to get it out, or do I have to take the other... let's see. It's got some big caps in it though, which I should check if they're discharged before I go prodding it with my hand. Oh. The rear power connector is a separate module, maybe? There we go. Or did it just bend off the circuit? Oh, it just bent off the circuit board. I know I used a screwdriver, but I didn't apply that much force to it. That's just really shitty. So it's got this massive heat sink on top and on the bottom. It looks like some thermal compound too, is it? Oh, this bottom plate's not even really attached. And is this thermally conductive plastic? I mean, it's insulate the bottom, but they're putting like some kind of thermal compound looking crap directly onto this plastic. I mean, is that plastic going to conduct heat? Or is that just like both a thermal and electrical insulator? I'm guessing it's both a thermal and electrical insulator. Let's see. What I'm going to do is just heat this up right next to my finger. Oh no, it just melts. Yeah, it just melts. I mean, yeah, that's just plastic. That's not worth ruining a soldering iron tip over. So that's dumb. I mean, I get it. There's a lot of metal sticking up there, like leads from the various components and so forth. So you can't just have metal on the back, but unless that's also for shielding, but then again, it's not grounded. Like, there's no connection point between this metal and like a ground plane in here. I don't even know if this is thermal compound. That just might be some kind of goop they put on to sort of keep this in place. Just so I don't get that goop all over my bench, I'm just going to temporarily put that back on the back. And then we do have a lot of goop here, which it kind of surprises me, because I thought that would be in the UGREEN power supply, but not necessarily in this one. Oh, frig. So here's the deal. See that tiny little end of a screw right there? On the other side of that is, I don't know, a transistor, a diode package, MOSFET, whatever it is. And that's the screw that holds that component to this heatsink / heat spreader, right? Then there's another component back there under this folded over tab, which also has a screw in it. So the two things holding this heatsink on is that screw and that screw, both going into components, both of which the screw head is inside the device under this metalwork, and pretty much impossible to unscrew. So the only way to get this off is going to be by desoldering, well, both of those components, I guess. It doesn't look like it's screwed onto anything else. So at least that's good, I suppose. And just getting back to the UGREEN for a moment, it's warm. It's got a decent amount of warmth to it. As you can see, this is reading 34 degrees, but it's not what I would call problematically warm. There's no absurd hot spots on it. We can let that cook for a little more. Alright, we'll get rid of the hammer and screwdriver, go to a slightly more refined method of disassembly. Alright, desoldering gun should be heated up now. Let's go after this component first. Okay, hopefully that'll come free now, if we got a good desolder. And it's also got all this gunk on it, so I don't know if I'm pulling on it, the component is still holding it in, or all that goop is holding it in. Ah, there we go. Yeah, it was just still like crusted in there. Alright, what about this guy? Does he want to move? I don't think that's holding it in. That seems pretty free. There we go. Haha! So all this goop here doesn't really look like it penetrates down to any components. Let's see if I can get that out of there. Perfectly in one piece. Is it just going to fragment all over the place? Let's see what they're gooping in. This is a very loose compound, whatever it is. Yeah, I mean, the only things that those are touching are these inductors, which I guess might be getting very hot. And this power supply, the circuitry just looks right off the bat too simple for what it's supposed to do. Yeah, it's just like putty. It's like blue tack, you know? It's very much the same consistency as blue tack. Probably hang posters on your wall with that shit. What happens if we apply heat to it? It's not even thermally conductive. Like, it's just getting a little warm on my finger. It's getting okay, it's getting a little hotter now. Yeah, alright. Alright, it is thermally conductive. It's just not very thermally conductive. It took a while for the heat to propagate to where my finger was, and this is a very low mass piece. So that should have heated up pretty quickly. Fine, it is some kind of thermal compound, not just there for looks, I guess. Oh, and what components are they sinking all the heat away from in particular? Oh, actually, before that, let's take a look. Now we're up to 43.8 degrees, according to that thermometer. Oh yeah, this thing is definitely feeling hot now, not just warm. Alright, so let's see what we got here. Alright, we got a hot spot of like 63 degrees. This side, a hot spot of 54. So yeah, my multimeter here is reading about 10 degrees low. It's unfortunate. I gotta get... Ooh, is it hotter on this side though? I gotta put that bottle there because it's picking up the heat of the desoldering gun in the background and changing its scale completely. No, okay, around this side we also have like 53.7 degrees. And what about around back? 58.2. Alright, so it's hottest on the front still, but that again could just be the high amperage connection between the USB plug in the USB port. And what about, oh, I didn't check the top. I'm going to guess it's about the same. Yeah, hotspot of 56 degrees. I'll take a wide angle shot. It is a lot more evenly warm. The hotspots are less severe and less localized, so I think my original suspicion was correct that this is probably chock full of thermal compound. Maybe not this exact stuff, but it's probably absolutely packed with that to spread the heat throughout the case and to bring it to the outside. We're dissipating 25 watts of heat in this relatively small box, so it's obviously going to get warm and even hot eventually. I feel like really for a power supply of this magnitude, it needs some kind of active cooling, which has its own downsides, of course, but if it had active cooling, it would probably last a lot longer because the components wouldn't be getting quite as hot. Although, in this case, if this is chock full of thermal compound, the outside temperature might actually be very similar to the temperature of the components in the inside. So it might not be that bad. Unlike with this guy, let's get back to that. Well, the old trick is to rub some thermal compound on it. Let me just literally dust off the old, whatever this is, microscope. Well, you can't even see the gray of the thermal compound in this with the oblique lighting. Runshin. Oh god, that's a huge model number. Okay, well, according to this Chinese document, it is a 650 volt gallium nitride power transistor, a FET, and 403. Great. Can't even view the datasheet or whatever that was supposed to be in the first place. Runshin. Alright, well, there are the specs if anyone's really concerned. And that component was this one here on this tab that was facing the front of the device. Or the back of the device, rather. Then for this one, is it the same? Ah, it is the same. It's the same component. Alright, fair enough. So two of the same component. Seems like only yesterday that almost every single tech YouTuber was shilling this product. Not me, though. That's why I bought it, though, because everyone was shilling it. And it's actually still pretty decent. But that must have been like 5-7 years ago. Wow, time flies. Alright, we're up to, well, 53 degrees according to this, which is probably more like 63 degrees per... Oh, yeah, that's definitely hotter. Because I can't really touch that for too long. A nice, even 69 degrees max right there at the top. Nice. Yeah, 62.1 right here on the side. So just about 10 degrees off. So just add 10 degrees to that. Should be roughly correct. Oh, wait, this one's crapping out. I didn't even notice that. Ah, so I think it's entering thermal protection mode. Although this one did stop working earlier for no apparent reason. Oh, and this one's also crapping out. And this one's only taking 1.5 amps. But that's actually a good thing, because this is trying to save itself when it's only at about 60 degrees C or 65 degrees C in that range. And it's already shutting things off, rather than shutting things off when it's already at 100 degrees. Or thereabouts, and not shutting enough stuff off, as the other one didn't. But maybe even without these additional loads, or these loads fluctuating on and off, yeah, that one just does not seem to want to... I'll leave the load on, so it keeps trying, but... and this one seems to be... Oh no, it just cut out. But again, it seems to be prioritizing these two ports. Alright, and these transformers at least do look ostensibly like they have safety insulation, like double insulation on the secondary at least. Or maybe triple insulation, even if the wire is lacquered, then some insulation, then another sleeving over it, at least at the end where it gets bent over and might contact other conductors. But they're also the safety type where the taps are actually kind of away from the windings. Not by a lot, but by more than a really cheap transformer would be. And they both have markings, 22 volts, 8 amps. I mean, 8 amps seems aggressive for this size of transformer. The interesting thing is LD050T1, LD050. So I guess these transformers are custom made for this product, or maybe the product is just model numbered after the transformers. I don't know which way they went about doing that. And that's why this transistor would not move out of the way. It's because it had this white goop on the front of the transistor, which was holding it in. So even though the pins were loose, still wouldn't pop right out. Otherwise, not too much on the top here. I mean, these must be input caps. They're 100. I mean, they have a 105-degree rating on the markings. Whether they are or aren't, I don't know. And they're 400 volts, which means they should be appropriate for 240-volt mains, which is great. And they're 100 microfarads. And my wager would be that they're wired in parallel. Oh, I didn't actually check if they're discharged first. I did even say I want to discharge these caps, or make sure they're discharged before I go messing around in here. Yeah, nothing spicy happening there. I think we're good. Yeah, we're good. Oh, maybe they're not in parallel. There's no conformal coating on this, right? Well, let me just see if I stab right next to its own... Yeah, no, there's no conformal coating or anything. So are they in pairs then? Okay, so that goop is covering probably a couple of full bridge rectifiers, or... Oh, okay, if those are rectifiers... Okay, so these two caps on the end here are in parallel, and I'm guessing these two... Oh, and then the two more are the same, or at least they look the same. I mean, I'm not going to go through every single component on this board, but I at least want to see what the major ones are. And these markings are actually legible with the naked eye. But yeah, we got AC in on the bottom, DC out on the top. Alright, WRLSB. There we go. So it is just a standard bridge rectifier. Thought maybe they'd be using synchronous rectification or something, but no, they're just distributing the load across multiple bridge rectifiers. These are the other two, which, yeah, they're all the same. Now, are those rectifiers all paralleled up? Oh, they're actually using these as diodes, basically, or as diode packages, because these two legs, that's the AC side, they're just common together, as are these. Yeah, so these all come together, these four, and yeah, and these four are all common together. So it's basically, they built a full bridge rectifier out of 4 full bridge rectifiers. I mean, it's not as stupid as it sounds. They're just using, like I said, the diode packages and the heat spreading inside of them. Because these probably have a decent current handling capability, which I did not even notice when I looked at this really quick. Yeah, rated 1000 volts, 8 amps. And so they're just spreading the heat across 4 of them, essentially. And let's see what's under these. That's got to be something getting hot. And that's what was covered by the blue tack, but it's illegible. Let me just wipe that off a little bit. Is that first one a Q or an O? I think that's just a bit of crap down at the bottom. I think it's an O. No. Alright, I don't know. I'll give up. I'll look into this part more when I edit this video. Is that a 69? Okay, next we got another goop. Oh, there's nothing under that. I guess it's trying to sink heat from the other side of the board right there. Good luck with that, but okay. And what do we got under here? Another mystery chip. Alright, it's the same as the other one. That's got to be a Q, because it also has that little leg kind of sticking out of it, almost. And the only other multi-pin ICs back here are this one. It's 8-pin chip. And what might be the same one. Yeah. Down there by the outputs. But otherwise, for what this is very sparsely populated. Very sparsely populated. And there's a lot of connections between the primary and secondary side. I'm assuming that this line right here would be the spacing between the primary and secondary. And it's fairly generous. But yeah, are those all like optocouplers? Why so many? Alright, looks like 2 pairs of the same. So it's probably 2 separate power supplies, I'm guessing. Because we have 2 of these FETs, gallium nitride FETs. We have 2 transformers. And then the output. So, let's see, is it obvious which are coupled to which? Very sparsely populated. What are those two little components down there? Oh, there's a fuse right next to the AC input. Yeah, and then caps on the output side are fairly small and fairly sparse. They're 680 microfarads. I guess they're all 25 volt 680 microfarads. So it's like 220 micro on the USB A ports, and then some chunkier caps on the USB C outputs, I guess. Yeah, it doesn't inspire confidence or trust. I mean, it's not like horribly made. It's not as much of a disaster in here as I thought it would be. But yeah, essentially it's two separate power supplies. If they sold this as maybe like a 200 watt power supply, but it had to be 100 watts on one half and 100 watts on the other half, I guess I could believe it. But yeah, not the greatest looking in the world. I'm going to run it with the cover off so you can see where it's getting super hot when it's under load. I'm going to guess mostly on the back. And I'm going to guess a lot of it will be these rectifiers. And nice segue, speaking of heat, we're up to probably 62 degrees. It hasn't really gone up too much. But now this one's been shutting off more. And this one's still just oscillating on and off. So it's really throttling the output to keep its thermals in control. Which, like I said, is a good thing. But it's also disappointing because this is rated 300 watts, but it can't output even 250 watts for more than like 30 minutes, which is that's, to be honest, pretty lame. Even though this definitely has a better quality feel and gives me a much better impression in what it's doing here than this guy. Still not exactly thrilled with this UGREEN power supply. Alright, so on the front, we now have 68, whoops, I hit the camera, 68.0 as the hot spot. On the side, 62.8. So yeah, just about 10 degrees off still, of course. Back, yeah, it is sinking the heat pretty evenly around the whole thing. And it does seem to have kind of stabilized. Because this is at least good for sort of just keeping an eye on the trend, even if the temperature is not completely accurate. So this UGREEN isn't a bad power supply necessarily. I can't say it's, shitty overall. It's just its specs are writing checks that it can't cash with actual output. But, also pretty much unity power factor, so automatically much better than this guy in that regard. So it has power factor correction. It's thermally throttling at a much more acceptable level in my opinion. And I'm probably not going to do a teardown this just because I will use this for something. I always have need for USB power supplies. And I have a feeling it's going to be a one-way trip to tear this down because it's probably really packed in there. And I'm guessing there's some three-dimensional geometry with the circuit boards. But also it's probably basically potted in here. So it's going to be an extremely difficult teardown. Probably won't get it back together. So leave it functional as is. But I can't recommend it because it says 300 watts on the side of it in big honkin' numbers, and it cannot output 300 watts. Even according to its own manual, it can only output 300 watts in a very specific set of circumstances with very specific voltages and loads on each of these ports, and you can only pull current in very specific anal retentive combinations from these ports. And that's going to annoy most people anyway. It's going to annoy me too, because like I said, I'm not keeping this. Like, what am I supposed to tape this around the power supply and carry it around with me? No. Like, if I was going to be using this on a day-to-day basis, carrying around my luggage or something while I'm traveling, I don't want to have to refer to this all the time. I'm never going to remember all these permutations of the way you can plug things in. It's just asinine. Like, just fine, rate one port 100 watts or 140 watts, whatever. Rate the next two ports 60 or 65 watts. Rate the last port 20 watts. I don't care. But just rate them to what they can all output at the same time max, Or I'd even be fine. It says 300 watts in the case. If the first three could output 100 watts each, and then the last two would just shut off, I'm fine with that too. As long as it could output 300 watts in any reasonable combination. But instead, it's so specific. Why so specific? And I know it's to do with the architecture internally of the power supply. Like I said, like this one is actually just two power supplies in one. Who knows how this one's laid out topologically. But I don't care. I don't like it. So, both of these were kind of duds, unfortunately. Before I load test this with the cover off so we can see what it heats up, I do want to point out that each of these USB-C outputs seems to sort of be its own power supply. It's got an inductor and a capacitor down there on each of these daughter boards, as well as some circuitry for power delivery negotiation and for controlling, presumably, the buck converter, I'm guessing, that's on each of those boards. And the USB-A ports is similar. They're paired up, so there's one capacitor, one inductor, and then a couple of chips on the back here. They don't have their own daughter boards. And the USB-C ports do certainly look like they're paired up. You can see these two are common together. That's got to be a voltage supply rail because it's got a thick-ass solder pad. I think that's either the positive or negative. The opposite pole is going to be on the other side of the board. So these two are paired up, these two are paired up. And as for the 65-watt ports, this one is paired with this one, because you can see there's a track going there. And this one is paired with this one. Not sure where that track is heading. It's probably on one of the other layers. Then for the Type A, yeah, it looks like it's got two separate power rails coming into either side. So again, each of these two ports is paired up. And so it is two completely independent power supplies. The output ports are just a little convoluted as far as the current path goes. But anyway, before I can get this up and running, I have to solder this back on because of those two components. And I think for the top, I'm not going to stick all this compound back in because I really want to see where we're getting hot spots, and obviously that's going to obfuscate it by spraying the heat out. Alright, should be good. And just for now on the back side, I'm going to put these little medallions of goop back on there. Because I'll take a look at the top first, although we're not going to see too much with that shield in place. But I don't want to burn out any of the components on the back side while we're looking at the top. And then I'll turn it over, take all that crap off, and we'll see what gets hot on the bottom. And obviously, since this metal plate is here, we're just going to have to kind of look obliquely with the thermal camera, but we'll see what happens. Alright, let's see if it blows up if I messed anything up internally, but plugging it in now. Nice. Unplug it and let me just get some loads hooked up. Okay. Yep, and we got output, 20 volts on all these, and 3.25. Alright, let's see where we are on the front of this thing. Currently at a high of 64 degrees on the front right away. See if these caps are getting warm. 129.4. Something deep in there. What was that? What about this little USB-C daughter board on the side? That's got a chip at 84 degrees. Really got to get a macro lens. All our outputs are still holding stable. Now let's take a look at the back. I'm not too sure about the emissivity of these. Like, it seems a little reflective. But let me just get a picture anyway. So high of 85.5 on this. It looks like a diode. I'll have to double check that. Let me just power it off for a second because I'm not going to be able to peel this off with the gloves. And just make sure these caps get discharged. Whoa, that one was quite charged. Yep. Okay, now I don't know how long I can really run this without these little medallions of nonsense on there, because even though they're not doing much to sink heat into this plate with that plastic in the way, at least they are spreading the heat out and wicking some of it away from these components. So, you know what, let me, just for the sake of argument, just turn down the load. We'll do 130 watts just between these two loads. Just so this thing doesn't blow up right away. And now let's see what we got here. Oh yeah, 72 degrees. Alright, so this is the mystery chip that I couldn't find the part number for. And that is right now at 70 degrees. Which isn't terrible. And this rectifier right here is the hottest one at 69.3. But then these other two rectifiers down here right now are basically not warm at all. Let me just get those in the field of view. Yeah, I mean, they're basically cool by comparison. Oh, I didn't even notice. That's because right now we're only drawing current from one of the two power supplies. Because this one's just kind of flaking out on me. Let me, get the voltage back up, turn that back on. And now I wager we're going to see these two heating up. Oh yeah, I can already see it starting to glow a little more. And then we should also see this chip heating up, which was also cool just before. And yeah, it's definitely starting to glow. Alright, well, you know what? Screw it. Let's push this as hard as possible. Really load it up, and oh yeah, right off the bat, I mean, this chip's already at about 84 degrees, 87 degrees. And now we can see these diodes at the bottom getting much warmer. Well, that might just be a reflection. Let's see, can we get the side of the Actually, maybe that wasn't the transformer, because the transformer doesn't look that hot on the side right here. There's a transformer is that, like, dark orange area in the middle. That 140 odd degree area was a reflection off the metal plate. Oh, actually, there we go. I got a really oblique angle, so there's no reflectivity issues. And it looks like that FET is at like 114 degrees C. The one like deep in there. Then we get 123.1 on this chip up here. Diode packages are all around 120. And as for the little USB-C daughter board, I'm actually seeing something behind that that's 113 degrees. And 150.2 deep in there. 132.4 up there now. Alright, well anyway, I think that gives a pretty good idea of what the thermals are like on this board. So, I guess I'll shut it down. Just kind of curious how hot this feels. Oh, that is pretty hot. It's not too bad. Just looking at that strip of tape, it's about 64.8 right there. Actually, I don't need this glove for electrical safety anymore, but I kind of need it for thermal safety. Let me just get this unplugged. So, a couple other things I want to check. Let me just get this out of the way so I don't touch it by accident. I am curious to see what this cable's like. And obviously I don't mind destroying this because it's a real piece of crap. Wow, the table's like almost burning hot right there. Which makes sense. I mean, yeah, real thin conductors. The ends, looking at the end cross section though, they do look like they're copper. I'm really surprised not aluminum, but let's see. Yeah, I do believe that is copper. Well, the last thing I'm going to do, I guess, is just an insulation test between the primary and secondary. Alright, let's socket and see. Actually, this thing can only do 500 volts. Well, let's see. Alright, and this is just to see the isolation between the primary and secondary. We'll go straight to 500 volts. It's on insulation test, and yeah, good. Greater than 1,000 mega ohms, which is what we want to see. I have one that can do 1,000 volts. Let me just grab that. This is a less reputable brand, in other words, basically a no-name brand. But nonetheless, let's see what it does. Go straight to 1,000 volts. Alright, so it looks like it can withstand 1,000 volts between the primary and secondary. Just switch it up, we'll go the other way. Yeah, I mean, looks good. And just in case that one was a little disreputable, let's try this one. Yeah, with the other polarity. Also, good. Okay, so it can withstand 1,000 volts between primary and secondary. Nice. Well, thanks for sticking with me this long, if you've been here the whole time. So yeah, this one, as expected, was kind of a piece of shit. I mean, it claimed to supply 700 watts. I kind of knew that wasn't going to be true going into it. I actually didn't really expect that it would be able to supply 360 watts, which it was. So in fairness, I mean, it did do something. It's not a complete dud. But it gets way too hot pretty quickly. And I wouldn't expect it to last long. And it's kind of a hazard as it is. So skip this, even if you find a good deal on it. It's going to be more trouble than it's worth, I have a feeling. As for the UGREEN, reasonable quality power supply, seems to be well made. I have no major problems with it, no safety issues with it. That being said, not really a fan of the way the ports are not usable in an intuitive way, that you have to draw a certain current from certain ports at certain times in certain combinations when the moon's in the right phase and the Doppler radar is upside down. That doesn't even make sense. I can't say like this is crap. It's just I wouldn't recommend it because long run it's going to be more hassle than it's worth. You're going to try and like plug 2 laptops and a tablet into this, and you're going to wonder why one of them keeps disconnecting from power. And no one's keeping this CVS receipt sized manual that's mostly just diagrams of how you can plug this in. I mean, or plug stuff into this. Absolutely absurd. So yeah, this video was a bust, but it's kind of fun, just especially investigating the shitty, cheap power supply. That was the one I was really focused on because the UGREEN was an immediate sort of disappointment. Anyway, thanks for watching. I know I said I might wrap this one in a towel and kind of destroy it, or let it destroy itself, but I don't know. I don't really feel like doing it. Who cares? Who cares? It's either going to ruin one of my towels and just prove I was right, or shut down politely and prove I was wrong. Either way, it doesn't really help me out. So, yeah. Until next time, whenever that may be, I've been Scott. Like and subscribe and all that stuff.